A spontaneous and unrehearsed interview.
Welcome to the 82nd episode of Curiosityness. I'm Travis DeRose, the host, the guy talking to you, and this is Curiosityness, where we talk about things that you're curious about. And this episode, I hope you're curious about 3D printing and what the heck happened with it. Because remember when we were promised, like, just push a button and you'd be able to 3D print a soup spoon right in your house? You wouldn't have to go out and buy it or order it and wait for it to be shipped. It was just a push button thing. I remember being promised that, in the late 2008-9 era. But it's never happened. Here we're 10 years plus later and we haven't seen it. So what the heck happened? Well, that's what our guest today, Jaime Bonnin Roca, is going to share with us. Hope I pronounced that right. Sorry, Jaime, I asked you and think I remembered it correctly. But it's a fun episode. If you're interested in 3D printing, you're really going to love it. Jaime's got a great perspective on it and kind of what really did happen. So we dig into that. Why 3D printing for the masses of people isn't really here yet. Who is kind of using 3D printing right now. And kind of the fun. We also kind of dig into like the hype of what is possible and what is already sort of happening with 3D printing. So it's a fun episode. Buckle in. Let's get going. Here's 3D printing and Jaime. All right, Jaime, welcome to the show. Thanks for being on.
Thank you for the invitation. I'm very happy to be here.
Yeah, man. I'm excited to talk to you because you wrote or helped write a paper called Getting Past the Hype about 3D Printing, correct?
Yes, that was part of my PhD dissertation.
Okay. So that sounds impressive there. You might know what you're talking about.
Oh, well, it depends on who you're talking to. So
okay.
Many people must know a lot more than me, but I know more than other people. So.
Wow, okay. Very humble. I like that, Jaime. So, let's just kind of get into it. Let's start with the basics. I think we've all heard, everybody listening has probably heard the term 3D printing, and we know generally what it is, but can you just kind of give us an overview of what 3D printing is, how you define it, and, kind of give us a starting point like that?
Sure, I can try. What is interesting about 3D printing is that nowadays there's so many things called 3D printing that it's really hard to give an overall definition. Mm-hmm. But I would say 3D printing is basically manufacturing something in a way that you are adding material, usually layer by layer.
Okay.
Instead of, let's say, getting a chunk of metal and cutting the edges until you have the final shape.
Right, okay.
Or pouring molten metal into a mold, which would be casting. So the advantage would be that as you are printing layer by layer, you can have much more accuracy and you are wasting less material because you can control much better where your pencil is.
Right, okay. That makes sense. So you're saving material because you're not having to shave it away. It can be more accurate. So you're literally adding material, and just it's kind of like additive manufacturing is kind of the term that people use, right?
Yes. Or
is that different?
I believe the field has gone through different stages.
Okay.
At the beginning, it was called rapid prototyping because these technologies were not good enough for production, but they were very good in creating quick designs. So it was very useful for product development teams.
Right, okay.
Then the technology achieved a level of sophistication, which was high enough to start making things, not just prototypes, but real components. And that would be the 3D printing, and that's when you see the maker revolution, especially in the early 2010s. But because that term was associated with the maker community, I heard from industry members that they were not very comfortable using that same term, because if you are making, I don't know, turbine blades using a very expensive machine, like $1 million machine, you are not doing the same than an entrepreneur in a maker space playing with a toy printer.
Right.
So,
okay.
So they came up with this term additive manufacturing, which sounds cooler and more professional, but it's basically the same.
Okay. No, that sounds right. So they just needed to make it sound a little cooler, more professional, but so that makes sense. And then, so we get what 3D printing is, and then what kinds of materials are being 3D printed? Is it a whole bunch of things? Is it specifically one type of material, or what's the scoop on that?
The sky is the limit.
All right.
Right now, there are some materials which are more advanced than others. I would say in polymers, the important thing is that they need to melt at a relatively low temperature, so you have a lot of thermoplastics. The problem with that is also that you cannot use it for high temperature applications because they melt.
Oh, okay.
For metals, you have steel, titanium, aluminum, tungsten as well. So there's a huge variety. The problem with metals is that you have to be very careful with corrosion, and you need to take care of the atmosphere. So you need a very close environment so it does not set on fire.
Right.
And then you see crazy things. You can print concrete to make buildings. You can print stem cells to create organs. You can print liquids and gels.
What?
Yeah. The craziest thing I have seen is to print like a liquid gel inside a liquid gel.
Wow. Why would you want to do that?
Well, when I saw it a couple of years ago, it was very early stage R&D, but I believe it's to create soft tissues for humans. Of course, you cannot print gels or liquids because, they fall.
Right.
So the idea is you play as if you had water and oil, so you have two bodies with different density. And if you are really, really accurate, where you put these oily bubbles inside the water, you can create a structure.
Whoa.
Inside the outer liquid.
Wow, that's crazy.
Yes, and then you melt it, and you end up with what you want.
Man. Okay, that's insane. I've never even heard of that. Wow, okay. So this is like what's happening with 3D printing, as we're hearing about all these, cool, crazy new materials and these possible applications and everything like that. I guess let's bring it back one step real quick. When did 3D printing kind of get started?
Well, the first patents were in the 80s.
Okay.
Now, the field evolved relatively slowly. Right. First, because it was very expensive, and developing a new manufacturing technology takes a long time by itself. But also many companies were waiting for these patents to expire to commercialize their own solutions.
Right.
So you will see in the first decade of the 2000s that once the first patents start to expire, you see many different companies trying to sell their own machines. And the good point about it is that, of course, that brings down price because there's more competition, there's more innovation, more materials, more interest in general. But of course, at some point, the market was a bit saturated, and there were so many 3D printing companies that they were cannibalizing one on another.
Right. Okay.
That was with polymers first, and now something similar happened with metals, but still working with metals is very expensive.
Okay.
So the industrial situation is still going slowly.
Okay, I see. And then, so kind of, I believe you said kind of like the early 2000s was kind of when we had the boom of a bunch of competition. Was that correct?
Well, a bit late. I think it was 2000 and... Well, I should have brought my notes. It was towards the end of 2000. It was 2008, 9, 10.
Okay.
That the price started to decrease really quickly, and you start getting 3D printers under 1,000 euros or dollars.
Right. Okay.
And that
yeah.
was like the psychological mark, because once you have something under $1,000, you can sell it to makers, and you can have it at home, and you can start playing with it, and then you have a community of people who create portals. They upload their designs. You have meetings of these people. Until the price is not low enough, it's really hard to reach a wide audience.
Okay. No, right. Yeah, because I kind of remember that in, the 2008, 9, 10 era where I started seeing a lot of stuff like even on Kickstarter, like new 3D printers that you could buy for a few $100s up to $1,000 and stuff like that, where it seemed doable, and then you could make all this stuff at home. And like reading, it was on on Wired and stuff, they were telling us about 3D printing and what it kind of meant for the person at home and everything. But what was kind of promised during that time, or what was the hype about 3D printing?
The question would be, what was not promised?
Oh, okay. Jeez.
Because 3D printing, and I want to say 3D printing has many advantages, but definitely I think the expectations were a bit overblown, because everyone was saying that you could do almost anything much more efficiently than with traditional manufacturing, and you would be able to be at home, click print, and then almost immediately have your own component made at home, and that would change the whole supply chain of how things are made, and that consumers would be empowered to create their dreams. And
right.
A lot of marketing.
Yeah, totally. Because I remember hearing, oh, you need a new, even like cooking utensil or something. Well, you don't have to buy it online and have it shipped or anything. You just click, go online and order the model or whatever, and then just click print, and it'll be printed for you, and you'll have it right there.
Yes, right there after 5-6 hours of waiting, and one in each 3 times, maybe the machine breaks in the middle of the process. The problem with, now it's much better, but 10 years ago, these machines were so unreliable. I was speaking with the director of a makerspace,
mm-hmm.
and he was telling me that he hated 3D printers, that they were the most useless machines in their workshop, but that they were a good marketing tool. Okay. So whenever a politician or the newspapers or radio program came, the first thing was 3D printers. Okay. But then if you spoke with the people working there, the work done by the 3D printer was minimal.
Really?
Yeah.
So it was just kind of too early at this time, and maybe even now, where it wasn't as easy as just clicking print, because, well, why? What were the issues?
Well, first, you need to know what you want to print, right?
Mm-hmm.
Because if you want a mold for the cookies, now instead of having 4 options, you have an infinite amount of options that you can design, right?
Right, okay.
So where do you go? Do you go online and look for a design, or do you design it yourself?
Okay.
And that's the first question. Now, once you have your design, well, you need to introduce it into the printing program, which is a completely different software environment than the design environment.
Really?
Yes. And more or less nowadays, most of the plastic 3D printers use the same software, but it used not to be the case.
Okay.
And then you have the design, and depending on the printer, you have to specify all the parameters, like how many layers you want, and how thick, and where the support structures have to go. Because one of the problems, if you're making things layer by layer, is that if you do not add supports, they may fall before they are completed. So you need to add supports.
Okay.
The temperature of the nozzle, the speed of the machine. Of course, each machine has different limits. Depending on the material you use, all those parameters need to be different.
Right, okay.
And if you're using, let's say, a cheap home 3D printer, the most stupid variables, such as the humidity in the room and the temperature, or maybe you're passing by and you suddenly hit the table the printer is on, and that creates a small vibration. All these very stupid disturbances affect the process.
Jeez, okay.
So if you want, of course, if you buy a good printer, they are more reliable. But if you are at home, there are many, many things which can go wrong.
Man. Okay.
And that requires a lot of time to learn. So until you have learned how your printer with your material and your design philosophy work, it's discouraging for most people.
Right. No, I can imagine. That sounds incredibly time-consuming and frustrating too, because you can't just print something and have it come out. It's going to take a little bit of trial and error. So then it, like the benefit of convenience is gone basically, because it's not convenient at all to print, which is what you were sold on initially.
Exactly. So I think this is wonderful for people who love tinkering with tools and who love do-it-yourself activities.
Yeah.
But it's not for your average Joe. Yeah. So I would never spend 5 hours doing something unless the sentimental benefits I got out of it would be huge.
Right, yeah. You have to enjoy the process of doing that.
Exactly. Of course, then you can create your design and send it to a printing company and you have it shipped in a couple of days. But then it's not immediate, so you can just go to the hardware store and buy one cookie mold for it.
Yeah, right. Okay, so I see that. That makes sense. And then, like, tell me about if you were to try to design something yourself, kind of the modeling or 3D software or whatever that's required. Is that very user-friendly, or does that also require kind of a lot of knowledge and time to learn that?
Well, from my times as an engineering student, I can tell you that they have improved a lot.
Okay.
Because of the 3D printing explosion, now tools are much, much better than they used to be.
Okay.
So, the first time you open software and you have to learn it, and you need to spend a couple of hours.
Right.
It will also depend on how complex the geometry you want to make.
Yeah.
So if you just want a couple of cylinders, and a lid or a rectangular box, that's very easy to make. But if you want to really optimize the geometry, like you say, I want to use the minimum material for this component, or I want to create this heat exchanger so that the efficiency of the heat exchange is maximized.
Right.
Then it's crazy because you get super weird geometries, and of course, the more complex the geometry, the harder it is to make.
Yeah.
But if you want to make simple things, yeah, I would say in a couple of days, if you are motivated, should be enough.
Okay, that's not too bad, but still more than most people want with just clicking the button. So like obviously when this was kind of promised and hyped up in the 2008, 9, 10 kind of area, and even after, this stuff wasn't ready at all. But like, how are things kind of now regarding that and the consumer side, and kind of, are things being standardized with the layer thickness and temperature and material and stuff where we are being able to get to that just click print area, or are we still pretty far away from that?
We are getting there.
Okay.
And the situation right now is definitely much better. And it really depends on how much money you want to spend.
Okay, on the printer?
So I would rather have a $1,000 printer than a $100 printer.
Okay.
There are also many high-speed technologies being developed.
Mm-hmm.
So now it's much faster than it used to be.
Good.
And that is an advantage. And there are online repositories. One is called Thingiverse, for instance.
Right, I've heard of that.
That you can just go and download the design. So situation is much better.
Okay. So that's good to hear. I mean, is it like me just being, let's just say I'm not really interested in tinkering. I'm not a maker or anything like that. I just want to have more convenience in my life. Should I spend $1,000 on a 3D printer now to get that, or is that not here yet?
If you are hesitant, what I would do is the first time that you have a design you really want to print, send it to a company, to an expert who knows how to print that in good conditions.
Okay.
Wait for the result and check whether it is good enough for you or better or worse than you expected. So I would never recommend people buying any hardware without testing it first.
Right, yeah. Okay.
There are some details, even like material color, which may matter.
Yeah.
You may think that you're printing in a color, but then once it's printed, the color is slightly different, and for you that makes a difference. I don't know. So test it first. You can go to a makerspace if you really want to try how it works and learn. So there's no need to. I would not buy my own printer unless you were super motivated.
Okay. No, that's good. So even now in 2020, it's not really there to that convenience level. Well, first off, do you think we'll ever get to that time when like almost every household has a 3D printer, just like they have a normal kind of inkjet printer right now? And, instead of going to Amazon and ordering, the spoon and having them ship it to you, you'll just go to Amazon and it'll be printed out for you. Do you think we'll get to that era? And if so, do you have any idea when?
Now, it's funny that you asked that question, because right now with the Corona situation, I was having a conversation with a colleague at work. That he had a problem. He hadn't had a 2D printer to print paper for years.
Okay.
Because he would use the one in the office to print papers and to grade exams and all his activities.
Okay.
But now with the corona crisis, many people who must work from home have started buying printers. So he went to buy one printer and they were all out of stock.
Really? Okay.
I don't know how in the US the situation is, probably not as bad as here. But I would say that because of the digitalization process that we have seen in the last 10 years, even 2D printers do not sell that well.
Mm-hmm.
So in a world of data, so if you want to print something, what has value is your design, and your design is digital, and you can send it anywhere, right?
Yeah.
And you can store it in the cloud. So for the sake of being efficient and, I don't know, even environmentally friendly, why should everyone have a printer and not just have one big printer that we all share and which is better in quality?
Oh, okay. I see. So kind of like a community printer for like maybe a neighborhood or something, or even on a larger scale where it's printed, but then it's still shipped to you.
Why not?
Yeah, okay.
So the printer I have in my office at the university is way better and faster than all the printers I had at home.
Mm-hmm.
Right? So if I'm printing paper, I really don't care. But if I am printing stuff and stuff that I'm going to use, I really want the objects to have a minimum of quality.
Okay. Okay, so I can see that.
If you print a lot, it makes sense. But if you print once in a while, I think it makes more sense to have some community resources.
Yeah. No, that makes sense. So that may kind of be the next, like for the average kind of person and consumer, that might kind of be the next thing that how 3D printing really comes into our life is we're not directly involved with it, but we experience the products and the benefits of 3D printing that way, I guess.
I remember a couple of years ago that the postal services in the US were thinking about having 3D printers in their offices.
Really?
I don't know if it was USPS or UPS. I tend to mix both of them. But one of them did like a pilot. I don't know the results from the experiment, but it's something people are thinking about.
Okay. No, that's interesting. It makes sense when you kind of frame it the way you did. Okay, well, man, this is cool, Jaime. So now, I like how we kind of explained how this might happen or where we're at and where we may be for kind of the average person and the consumer and stuff. But how is 3D printing kind of being used today, like maybe on an industrial scale and, for like, is it really widely being used to print houses and buildings and that kind of stuff? Where is it at today on that side of things?
So it is way more used than you may imagine.
Oh.
Especially in the automotive industry, for instance. Because right now, the machines have reached a speed, especially with polymers, which is attractive for mid-volume production. So many plastic components, a lot of product development, medical equipment, medical implants. I would say most of the medical implants can be 3D printed, like hip replacements or teeth.
Really?
Yeah, yes. And that's a very efficient way of doing it. Adidas, the footwear company, opened the so-called Speed Factory that they were planning to use 3D printing at an industrial scale to print shoes.
Whoa.
And they are not cheap, but they are not crazy expensive either.
Okay.
So they are at the point that someone could really scan your feet, design the shoes for your feet, and print them.
Oh, that's so cool.
Yeah. In metals, apart from the implants in biomedical, a lot of aircraft components right now are printed, especially support structures. Some companies making engines are thinking of making turbine blades. Not the super critical ones, but some of them. Then what else? There's a lot of jewelry also made with 3D printing.
Really?
Yeah. So if you want a customized wedding ring, you can have one.
Wow, okay.
People are experimenting with carbon fiber nowadays. I don't think it's super advanced, but they are looking into composite materials to have really high strength. There are crazy projects about many things. So people right now are at the stage of exploring in every single sector where they can exploit the technology. Yeah. Here in the town where I live in the Netherlands, I believe it was last year, they printed a couple of houses.
Whoa.
In China, there's a lot going on, but it's hard to know what's going on there because it's very far. But here I can promise that the houses exist, and I know the people involved in building them. And
that's so
it's
cool.
Still expensive, but the construction industry is facing some problems. 3D printing might be able to help.
Yeah. So I think I've seen these. Are these the houses where it's 3D printed with like it's like a big sort of bead of cement type of stuff?
Yes.
Okay. Yeah, those are so cool. Because it's really just like, it's like a massive 3D printer that uses concrete to go around and build up walls and houses.
Yes, and there are several philosophies. So you could have one robotic arm printing everything. And I have also seen people having like Lego pieces.
Oh.
So you make a wall of, let's say, 6 feet long, and then you snap the different components. So you can create more complex structures by putting one next to the other.
Okay.
The advantage of that is that you can make bigger things. The disadvantage is that, of course, structurally, you need to ensure that these joints between one wall and the other are very well sealed.
Right, okay. Yeah, because that's kind of an issue with like how to kind of regulate 3D printing and testing components to make sure they're safe and, they're strong enough and things like that, right?
Yeah, that's what my dissertation was mostly about.
Yeah. Well, go ahead. Can you elaborate on that then?
Well, my work focused on metals. Metals are way more complex than polymers when you try to print them because there are many more things which can go wrong. And also you work at a much higher temperature. So if polymers melt at 300 degrees, for instance, for metals you may have to go over 1000 degrees.
Ooh, okay.
To melt them. And metals experiment something called fatigue.
Right.
Which is basically, if you have very small, but we are talking about very small holes inside the metallic structure, you may not be able to see it. But if it's a component that you are pulling and pushing constantly because you have a periodic load on it, then those micro holes may start joining each other and create a bigger hole. And this takes years. But let's say after 5-10 years, you may find that all those metallic components start to break.
Right, okay.
And you don't want that, right?
Yeah, probably not.
So the tricky issue is how to ensure that these holes do not exist and that all the structure is consistent.
Man.
Because you cannot get, at least as far as I know, the mechanical properties of the printed metals are not as good as when they are machined or forged.
Oh, okay.
Yeah, because once you print them, you need to perform a couple of heat treatments just to ensure that the component is good enough, and through those heat treatments, you also limit the maximum strength. So there's a lot of optimization of choosing exactly for which components you can print and for which you cannot. But one application which is very useful is when you have very complex assemblies. Imagine you have to join 5 pieces together into a single spot. So with a printer, instead of 5 components, you can have just one with a very complex geometry, because geometry is very easy to get with a printer.
Okay, I see.
So you don't need nuts and bolts and screws. You can save all that material and you can save all the assembly time. So there's a lot of optimization in the geometry.
Okay. Yeah, that's super cool. I love that. Where rather than combining multiple components, I mean, even on a large scale, like a whole airplane that's riveted together or something, you could just print the whole thing as one component.
Yes, especially for things which are not super critical.
Right. Yeah.
Like supports for the seats or for the luggage holders, things that if they break, well, it's not good, but the plane is not going to crash,
Yeah. That's cool. No, that makes a lot of sense.
I think the interesting finding during my work is that you can have 2 people inside the same factory working with 2 different machines which are the same machine model, printing the same part in theory with the same material. And if you test one component from one machine and the other component from the other machine, even if they are different machines, the same model, with the same material and more or less in the same place, the component will be different.
Oh, God. That sounds like a nightmare.
So that's a nightmare to ensure quality.
Yeah.
If you are making pipes for plumbers, those differences do not matter.
Right.
Or if you're making, an exhaust pipe for a car, that's not a problem. But again, if you're making turbine blades, you really want to make sure that you have the process under control. So companies are spending millions on increasing the robustness of 3D printing.
Man. No, that makes a lot of sense. That seems like such a nightmare to deal with. But yeah, for things like that aren't like super critical, that aren't under high pressure or a lot of weight or something, then that's great that stuff can start to be utilized. And especially like you said, the customization of something is so cool, where you could have a shoe or your foot scanned, and then the shoe is 3D printed, precisely and customized to your foot. That's awesome.
Yes, that's where the promise of 3D printing is.
Yeah, there's so many applications I could see for that. Like you said, like medical things, or like, don't they do even dental implants that are 3D printed?
Yeah. They can perform an X-ray of your teeth, and they can adapt the implant perfectly to your own body.
Man, that is so cool. Wow. And that stuff, that's starting to happen today even.
Yes, that's happening nowadays.
Man, so cool. So we'll just get to see more and more of this stuff. Man, well, Jaime, this was awesome. I love learning about this stuff, and you have such a great grasp and knowledge about it. I love it. So just to kind of wrap up, what do you kind of see as the future and maybe like a rough timeline of 3D printing? Like, what can we look forward to? Not to hype it up again, but
So what we are seeing now, and I will say for the next 5 years, we'll start to see low-cost metal printers.
Okay.
So the same way you had in the end of the 2000s and early 2010s, this low-cost polymer printer, now you have low-cost metal printers.
Okay.
And that's promising because the properties of those, how they work, they basically mix metals with polymers. They create the shape and then they melt the polymer, binding the metal.
Okay.
So that can be made relatively fast, or way faster than if you're going with a laser joining all the molecules, which takes forever.
Okay.
But as soon as you can print metallic components relatively quickly, I think a lot of replacement parts can be made much faster. Imagine if you have an old car or even a luxury car, sometimes you need a replacement part which is not in stock.
Yeah.
And you need to wait forever. So you could start having quick replacements, like a temporary fix for a couple of days until the final part comes, or even at home. For instance, lamps. I think lamps are very expensive and design matters a lot.
Yeah.
So if you could start making metallic lamps on your own, of course, always respecting, the fire prevention standards. You don't want to burn your house, but I think it will open up a new array of possibilities because metals are way more resistant than plastics and look better. So if you look at 3D printed plastics, if you do not know how to process them at the end, they can be ugly.
What do you mean by process them at the end?
When you print something at the end, the surface is not polished.
Oh, okay.
So you may need to apply some chemical substances or some physical process to polish it and then paint it on top.
Right, okay.
Depending on the color you want. So it is not just click and print, but even after you print, you need to make it pretty.
Yeah, okay.
But I would say metals are prettier by default.
Cool.
And then, well, I don't know. I think the whole stuff about printing organs is very promising, but it's going to take 15 to 20 years to ramp up.
Really?
I think I was reading that some scientists have made artificial hearts and kidneys. The problem is that until you test that this works and this does not create long-term negative effects,
yeah,
it may take a while. So I will not expect it anytime soon.
Yeah, you want those to work pretty well.
Yes. With construction, I think that printing houses is already a reality, but the main barrier is that the construction industry is very conservative and there's not a lot of skilled labor.
Okay.
Because people are used to build houses with their hands.
Yeah.
So shifting towards a digital paradigm, some big companies are doing it, but it takes a lot of time because you need to change the culture of the whole organization.
Right. Okay.
So, yeah, a decade or two as well.
Yeah. Okay. No, man. Well, this is exciting. Like, it was hyped up, and I feel like we're hyping it up again, but it's because it's so cool. It has so many possibilities, and we're starting to see the stuff happen, which is super fun. And you can even buy things. So, no, this was great. I really appreciate you coming on and sharing all this stuff, Jaime. So,
No problem. It was my pleasure.
Cool. Well, glad to hear that.
I think that there are reasons to be hyped up. But the reasons which were given at the beginning were the wrong reasons.
Okay.
So now I think we see many possibilities than 20 years ago, and that is indeed exciting.
Yeah, totally. Cool. Well, thanks again, Jaime. I really appreciate it and you sharing all this stuff, and enjoy the rest of your day, all right?
You too.
Cool. Thank you.
Thank you for inviting me.
Yep, of course. Well, there you have it. That's what happened to the hype of 3D printing. We got to get past it, but it could be coming again. So thank you to Jaime Bonnin Roca for being here and sharing all that. Really enjoyed it, learned a lot. Hope you did too. And thank you for being here until the end and hopefully enjoying, or at least listening to this whole episode. So that's it. Again, I'm Travis DeRose. This is Curiosityness. You can find us at Curiosityness.com, where we got some stuff on there for you to check out. Send me an email to Travis at Curiosityness.com. I'm on Instagram at Trav DeRose. And that's all I got to say today. And that's all I got to say. Okay. Goodbye.